welcome to Mechanical Words. So today we will practice some numericals of BHEL previous years. Okay, so this is the second part of our lecture. Okay, so let's start it, man. First start with, okay, so the thing I want to tell you that most of the questions of BHEL or any state AJE exams are from SOM and manufacturing, which is called production engineering. Okay, so SOM and manufacturing both consist the maximum part. Okay, both consist the maximum part in the state AJE and in BHEL exams. Okay, so today we will practice some of SOM questions, means strength of materials question. We haven't studied the strength of material in detail, like in kind of lectures, but we will do this. Okay, so let's go. Okay, so first start with a basic question, which is the unit of stress. What is the unit of stress? First option, Newton per mm square. Okay, C, Newton per meter square. B, kilonewton per mm square. Kilonewton per mm square, and the D is what? D is what? Any one. Okay, the unit of stress is, do you know the unit of stress? Okay, I'm telling you, Newton per meter square. Unit of stress. Okay, what is unit of stress? Suppose when we apply force, to a certain material, okay, the internal resistive force which occurs due to the force which we applied on that material, okay, that is stress. Suppose we are trying to suppose this one. Okay, let's put this one. Okay, suppose we are trying to elongate it. Okay, we are trying to elongate it. Suppose, but we can't, because the stress is occurring in this. Okay, we are putting this force and some kind of internal resistive force which is occurring, which is the internal resistive force which is occurring, and that which resisting this deformation. Suppose we are trying to deform this, but this is not deforming because of that internal resistive force. Okay, that internal resistive force is not allowing this material to deform, so that internal resistive force is called stress. Okay, and that unit is what? Newton per mm square. Okay, so let's go to the next question. Which is the deformation the deformation per unit length first option A, deformation per unit length, tensile stress. Okay, tensile stress. B, compressive stress. Okay, and the C is what? Shear stress. Okay, shear stress, and the D is strain. Okay, so what will be the answer? Tell me. This is a very easy question. What will be the answer? Okay, I'm not giving pressure to you because I didn't teach you the strong strength of metal, so I'm not giving any pressure. Okay, I will tell you which one is the answer. Okay, so the deformation per unit length is what? The deformation per unit length is what? Tensile stress. Not tensile stress means what? Achha, okay, first you have to know what is strain. Suppose this is a material. Suppose this is a material and we are giving this force. We are giving this force, okay, and after giving this force, the means the exact force which it requires to deform, okay, which it requires to deform means the force should be above the threshold, threshold resistive force or threshold stress, okay, threshold resistive force, okay. So suppose it is deformed like this, okay. So this is the deformation part. This is the deformation part, okay, and this is deformed to this, and suppose this its length is suppose 1 meter and its became 2 meter, okay. So that means it deformed, okay. So this deformation, suppose this is a kind of tensile stress. This is a tensile stress. Okay, one thing I need to do. Okay, I am erasing this. I am erasing this question. First question. Okay, I hope you all noted it. Okay, so you have to note down with me. Okay. Like I say, every day you have to note with me because we together are studying. Okay, I am also student. You guys are also student. So let's begin. Okay, suppose this is a material. Suppose this is a material, we are giving some external force, okay, and this is deforming into that. Okay, suppose this is 1 meter and this is 3 meter, okay. It deformed due to this force, okay. Here the force we are denoting with P, that means the pressure, some kind of pressure is applied, okay. This is P and this is P and the deformation is occurring, okay. So this is a tensile stress, okay. Tensile stress means what? Tensile stress means the stress or the force which increases the material's length. The tensile stress is the kind of force or stress which increases the material's length, but here is also an option that compressive stress. What is compressive stress? Okay, so this is the tensile stress. I hope you all understood. The stress or force which causes the materials to increase its length, that's called tensile stress. That is called tensile stress. So this is a tensile stress. Okay, suppose we giving this is the material, we giving the force in this direction, P, okay. Suppose its length is 2 meter, okay. After giving this force, after giving this certain force, the material became like this, okay. So so this is, suppose this is its original length and it became, no, not what I am doing, one second. once in it. Okay. Suppose this is its original length. This is its original length. Okay, like this. And after giving this force, this material become this. Okay, this is its change in length. This is its change in length. Means the length which changed due to some force. This is suppose delta L, okay, and the final length it becomes, we are removing this part, we are removing this part, this okay, and its length became let's say 0.5. Okay, so this is called compressive stress. This is called compressive stress. That means the force which results a material to decrease its length from its original length, that is called compressive stress. And this deformation, suppose this deformation means this change in length. Suppose this initial length is 2 and its final length became 0.5. Okay, its final length becomes 0.5. So these changes occur, means the due to compressive stress the metal becomes shortened. Okay, the metal becomes shortened, and this process of shortening, this process is called deformation. Okay, this is called deformation, and this deformation, that means this deformation per unit length is called what? Strain. Okay, this deformation is called strain. If it is for compressive stress, and when the tensile stress occurs in this material, the deformation means the increase in length which occurs in the material. That increasing that process is called deformation also, and that process is known as strain. Okay, that process is known as strain. Means it's going to its initial length to a final length. That process is known as strain. Deformation process is known as strain. Okay, so I hope you all understood. That means deformation per unit length. Okay, means deformation per unit length means its option its you know what, its unit will be Newton per mm. Newton per mm. Okay, we use mm in our strength of metal or in measurement unit. So mm is we use, so that's why Newton per mm. Okay, so this is the, oh, not what I'm doing, no, sorry, not Newton per mm. Newton per mm square is the from unit of stress, but not strain. Okay, so the unit of strain is simply mm. Okay, mm. Simply mm. Simply mm. Its length is simply mm. Okay. So I hope you guys all understood. Okay, note it down. Okay, I hope you guys noted it. So let's move to the next question. Okay, these are some basic questions of strength of material. If you follow my lecture, or if you listen me carefully, then I'm telling you your concepts is becoming strong. Okay, when we do lecture of our, when we will do like in the the lecture in strength of material, there you can able to see that how much concepts your you have strong in, you have strengthened. Okay, so okay, what is the formula of strain? This is a question. The next question is, strain is equal to what? The first option is L by delta L, B delta L by L, and C is L into delta L, and D L plus delta L. Okay, this is strain is equal to, this strain is equal to delta L per delta L by L. Strain is equal to delta L by L. This is a formula of strain. Okay, what is delta L means? Delta L means delta L by L means change in length by original length. Change in length by original length. Okay, so this is the actual meaning of strain. Means the how much length is changing by original length, means its initial length. Okay, so this ratio is known as strain. This ratio is known as strain. Okay. Okay, so you have to answer this question. The next question we are moving. You have to answer this question because in few seconds ago we learned this. So you have to answer this question. Okay. Thing I'm doing. You have to answer this. Okay, when a body is subjected to, when a body is when a body is subjected to when a body is subjected to two equal and opposite two equal and opposite pools as a result of which the body tends to extend extend its length. Okay, tends to extend its length. The stress and strain induced is what? The stress and strain induced is what? Okay, option A is compressive stress, tensile stress. Compressive stress, tensile stress. compressive stress, tensile stress, then shear stress, tensile stress. Oh no, shear stress not. Tensile stress, tensile stress. Tensile stress, tensile stress, tensile stress. Tensile stress, tensile stress. Tensile stress, tensile stress. This is compressive stress. This is tensile stress, and this is tensile strain, and this is tensile strain. Okay. So when a body is subjected to two equal and opposite pulls, as a result of which the body tends to extend its length. As a result of which the body tends to extend its length, the stress and strain induced is called what? Pulls. Pulls mean what? This one and this one, PP. And push means what? P, P. Okay, this is push and this is pull. So if the force direction in the pulling direction, so that means tensile stress is occurring and tensile strain is occurring. This is the option. Done? Okay. Let's move to the next question. Okay, so the next question is, when a body is subjected to two equal and opposite forces acting tangentially across the resisting section as a result of which the body tends to shear off across the section. Okay, the stress and strain induced is what? The stress and strain induced is what? First, tensile stress, tensile strain. Tensile stress, tensile strain. Okay. Then shear stress, shear strain. Okay. Okay, shear stress, shear strain. Okay, when a body is subjected to two equal and opposite forces acting tangentially across the resisting section, as a result of body which the body tends to shear off. As a result of body which the body tends to shear off across the section, the stress and strain induced is what? I hope you all guessed the answer. Okay. So which one? Yeah, of course this one. Okay. Also, when a body is subjected to two equal and opposite forces acting tangentially. Okay, acting tangentially. Suppose this is a body and we are trying to push this body like in this direction, equal and when the body is subjected to two equal and opposite forces. Okay, two equal. So it's this one and it's going to this direction. This called shear stress and okay, so I think going to equal and opposite forces. Suppose this is going to this direction, no, not this direction. Okay, then this one is direction. Okay, yeah. Okay. So this force is like putting in this part, and this force is also going into this part. That's why the resulting its structure will be like this, like this. Okay, its resulting structure will be like this. So this is shear stress. This is shear stress, and the deformation which is occurring, that's called shear strain. Okay, so this is the option. Okay, so when we will study strength of material, then we will go to the detailed part of this part. Okay, of this part. So let's move to the next question. Okay, let's go to okay, the next question. Which of the following is a proper sequence? Which of the following is a proper sequence? Like, which of the following is a proper sequence? Which of the following is a proper sequence? Okay, here the first one, proportional limit, proportional limit, elastic limit, and then yielding and then failure. Yielding and then failure. Then B, elastic limit. Elastic limit, proportional limit, proportional and failure. Okay, yielding and failure. So which of the following is a proper sequence? Okay, this one, proportional limit, then elastic limit, then yielding, and then failure. This is a proper sequence. Okay, proportional limit. First, when we extend the material, okay, when we extend the material, it's go to the first proportional limit point, and then elastic limit point, then it goes to the yielding point. That's yielding point, from which the point means from which that point from which that is the maximum point, or that is the final point where the maximum elasticity works, where the that's the maximum point where the elasticity will works, and above that failure will occur. After the yielding point, if we extend the materials, then it will fail its elastic limit. Okay, so this is we'll study all this we'll study we will in future lectures. Okay, Hooke's law holds good up to what? Next question is Hooke's law holds good up to yield point. Okay, I am clearing your every single concept. Okay, Hooke's law holds good up to which point? First, yield point, C, plastic limit, and B, elastic limit. D, breaking point. Okay, so note it down first. Okay, I hope you all done, noted it. Okay, so Hooke's law holds good up to which point? Yield point. Okay, this is the option. Okay, so I'm solving this question so that you can understand it well. Suppose this is a material. This is a material. Okay, we are pushing a tensile, we are giving a tensile stress. Okay, tensile force or stress, what you can say, tensile stress. Okay, then the material becomes like this, this. Okay, metals become like this, and after elasticity means where this is suppose the elastic body, this is elastic body. Okay, and we are trying to elongate it, but what happened is, after it's going to the elastic limit, means like this is the elastic limit, okay, if it goes in this direction, like if it goes, it's above its elastic limit point, then it will lose its elasticity. Okay, this suppose this is the elastic limit, this is what, this is the body's elastic limit. This is the elastic limit of this body. This is the elastic limit of this body. When it goes above its elastic point like this, when it goes above its elastic point like this, okay, like this, it will lose its elasticity. Means we cannot, it will lose its elasticity. Means elasticity is a property that means when we extend a body or elongated body, it's again move to its initial position. Okay, it's moved to its initial position like a rubber band. Okay, imagine a rubber band. The properties the rubber band have is the elastic body have. Rubber band is the elastic body. All the elastic bodies have the same rubber band properties. Okay, so this is yield elastic limit, and also this elastic limit point is known as yield point. This is also elastic limit point is equal to what? Elastic limit point means yield point. Yield point. Okay, so elastic limit points means yield point. Okay, when this goes to the yield point and we are trying again to extend this metal more, it will lose its elasticity. So that's the function of yield point, and that is also the definition of yield point. Okay, I hope you all understood. So let's move to the next question. Yeah, I know that strength of matter is an interesting subject. When we will study it in detailed manner, then it will be more interesting. Strength of matter is very interesting subject and also very important. Okay, you have to know it pi by pi so that you can crack interviews also in PSUs or any other organizations. Okay, so let's go to the next question. Okay, so this is a basic theoretical question. You have to know this question. Suppose when a body, whenever a material is loaded within elastic limit, is loaded within stress is dash dot dash to strain. Okay, so if you have studied the Hooke's law, then you can surely answer this question. Then you can surely answer this question. Okay, whenever a material is loaded, whenever a material is loaded within elastic limit, stress is directly proportional to strain. Stress is directly proportional to, whenever a material is loaded within elastic limit, stress is directly proportional to strain. Whenever a material is loaded within elastic limit, stress is directly proportional to strain. Okay. Suppose we all know, we all study that suppose there is a material, suppose it's a material, okay, and we are trying to elongate it. We are trying to elongate it. Okay, when it is elongating, okay, so when it is elongating, the stress is directly proportional to strain. Means if we are giving force, if we are giving some force like 10 Newton, then the strain will occur 10 mm. 10 mm. Strain will occur 10 mm. Means stress is directly proportional to stress. How much stress is occurring? That much strain will occur. Okay. Okay. The amount of stress we are giving, that same amount of strain will occur in that material. That same amount of strain will occur in that material. So this is what we call the stress is directly proportional to strain. Okay, I think we're done. Let's move to the next question. Let's move to the okay. Note it down first. Note it down first. Okay. Next question. Okay. Suppose the ratio of linear stress to linear strain is called modulus of rigidity. Modulus of rigidity, say bulk modulus, see bulk modulus, B modulus of elasticity, and D is called Poisson's ratio. Poisson's ratio. Okay, the ratio of linear stress to linear strain is called what? Modulus of elasticity. The ratio of linear stress to linear strain is called what? Okay. So what is the formula of modulus of elasticity? Formula of modulus of elasticity is equal to linear stress to linear strain. So this is the formula of modulus of elasticity. If somehow you need to find out in the modulus of elasticity, then you have to use this formula. Okay. There are some numericals where modulus of elasticity is required to solve that question. Then there you have to use this formula, linear stress to linear strain, for modulus of elasticity. Okay, so let's move to the next question. Let's move to the next question. Okay, so modulus of elasticity is same as those of stress. Okay, now this question is also required, like the unit of modulus of elasticity. The unit of modulus, the unit of modulus of elasticity is same as, the unit of modulus of elasticity is same as those of first stress strain pressure, stress strain and pressure. B stress force modulus of rigidity, stress force modulus of rigidity, stress force modulus of rigidity, and C stress pressure modulus of rigidity, stress pressure modulus of rigidity. Stress force modulus of rigidity and this stress pressure modulus of rigidity and this stress strain pressure. Okay, first you have to know the modulus. This modulus word is coming this modulus pod is coming, okay, in modulus of elasticity. So here the stress, the unit of stress, is not equal to modulus of elasticity, not strain, not pressure. Okay, so this one is wrong. Stress, force, and modulus of rigidity. Okay, so here stress and modulus of elasticity, modulus of rigidity have the same, you know. So stress, force, modulus of elasticity, modulus of rigidity. Okay, stress and modulus of rigidity have same unit as the modulus of elasticity, but the force does not. Okay, so stress, pressure, and modulus of rigidity, these are the three unit, or you can say these three have same unit as of modulus of elasticity. So this option is correct. Okay, so note it down. Okay, I hope you guys noted it. So let's move to the let's move to the next question. Next question. When a simple when a change in length when a change in length takes place when a change in length takes place, the strain is known as linear strain, B lateral strain, C volumetric strain. And D shear strain. D shear strain. Okay, note it down. Okay, I hope you guys noted it. Okay, let's move to the question. When a change in length takes place, the strain is known as what? When a change in length takes place. Okay, suppose this is a material. Suppose this is the material, we are solving this question. Suppose this is a material, okay, and we are wanting to change it in any direction. Okay, so when a change in length takes place, the strain is known as what? So here there is no specification of length change. Okay, in which direction they are changing, how much length is changing, there is no specified in this question. So we will assume that it is linear strain. Okay, if there is no change in means the how much length is changing or in which direction, if there is no specification in this in the question, then we have to assume that that is linear string. Okay, if there is no specification, you have to assume that that is linear string. So this is how the option is A correct. Okay, here's another interesting question. We are moving. Okay, so you have to remember these formulas. Okay, the question we will do now. This question is formula based. Okay, so you have to remember this formula. If you go to know or remember the derivation, then I am telling you, you will not crack any of the exams, especially state AJE exams. Okay, there is no need to know derivation for those exams. Only you have to remember the formulas. Okay, the important formulas, not all formulas, the important formulas you have to remember. Okay, so the question we will do now is important in terms of state AJ or BHEL examination. Okay, the change in length, the change in length the change in length due to tensile or tensile or compressive force acting tensile or compressive force acting on a body, tensile or compressive force acting on a body is given by the first option P into A in A by E, B PL by AE. Okay, and the option C is E by P into L into A. E by P into L into A, and the D AE by PL, AE by PL. The change in length due to tensile or compressive force acting on a body is given by PL by A. Okay, change in length due to tensile or compressive force acting on a body is given by PL by A. So this is a strain, formula of strain. Delta L, this is the formula of strain PL by AE. This is a simple formula of strain. Okay. The formula. This is another formula of strain. Mainly the strain formula is delta L by L, but this is also a formula of there are many formulas of stress, many formulas for strain. So this is another one of strain formula. Okay, so next go to, so you have to remember this formula. You have to remember this formula. So guys, note it down first. Okay, pause the video, note it down. Okay, done. Let's go to the next question. So the next question is the modulus of elasticity. Okay, this question is also important but not, okay, 1 star is required, 1 but big star. Okay, the modulus of elasticity, the modulus of elasticity for mild steel, modulus of elasticity for mild steel is approximately equal to first option is what, 10 kilonewton per mm square, 10 kilonewton per mm square, C 100 kilonewton per mm square, B 80 kilonewton per mm square, and D is 210 kilonewton per mm square. Okay, so note it down. I hope you guys noted it. Okay, so the modulus of elasticity for mild steel is approximately equal to 210 kilonewton per mm square. 210 kilonewton per mm square. So this is, you have to remember. Okay, this you have to remember. This main solution is, remember, there is no any other option to solve this valuation type question. The only thing you have to do is to remember. Okay, note it down. You have to remember. Done? Okay, let's go to the next question. Which is a very important or interesting question. Okay, this kind of questions comes. Okay, if you see RPSC mechanical previous year questions, you will see that this question has came. So this kind of question is very important that I am going to solve. Okay, Young's modulus may be defined. Young's modulus may be defined as the ratio of first lateral stress to lateral strain. Option B, lateral stress to lateral strain, then lateral strain to linear strain. Lateral strain to linear strain. Lateral strain to linear strain. Then option C, shear stress to shear strain. Okay, Young's modulus may be defined as the ratio of what? You have to remember this, shear stress to shear strain. Okay, note it down with me. Note it down with me. Solution Young's modulus. Young's modulus Young's mod is equal to, okay, 1 second. Okay, I think you guys have noted it. Note it first. Pause the video and note it down. Done. Okay. So I'm telling you, you have to remember this formula. Young's modulus is equal to shear stress to shear strain. Shear stress to shear strain, okay? Shear stress to shear strain. Remember. Note it down. Note it down fast. Pause the video and note it down. Young's mod is equal to shear stress to shear strain. Note it down. Okay, done. Okay, let's move to the next question. Let's move to the next question, which is when a bar of length when a bar of length when a bar of length L and diameter D. So the thing I want to say is the questions we are doing, the objective type of questions we are doing, these are very important, okay? You will see in BHEL or in state AJE exams that this kind of questions copy ditto into their exams. Okay, so these questions are very important. Do this. This question has already came in, I'm telling you, in WPPSC. 1 second. I'm telling you, this question has come. If you see the previous year question, you will see WPPSC. This question has come in WPPSC. Okay, so we are doing the PYQ question. Okay, this question is very important. Note it. This question is very important. D is rigidly fixed and D is rigidly fixed at the upper end and hanging freely. Then the total elongation, then the total elongation then the total elongation, then the total elongation produced in the bar in the bar the total elongation produced in the bar due to its own weight. Okay, when a bar of length L and diameter D is rigidly fixed at the upper end and hanging freely, then the total elongation produced in the bar due to its own length, due to its own weight. Okay, first option is WL by 2E W square by 2E C WL cube by 2E, and the D is WL to the power 4 by 2E. Okay, so this is a question when a bar of length L and diameter D is rigidly fixed at the upper end and hanging freely, then the total elongation produced in the bar due to its own weight. So note it down first. Pause the video, note it down, then we will solve this question. Okay, this is a very important question. So we have to solve. Okay, we have to solve and remember the concept. We have to solve and remember the concept. So I hope you guys noted it. So let's move to the solving part. Okay. So here the question says that when a bar of length L and diameter D is hanging freely from an upper end. Okay, see the questions on your copy that you noted. Okay, that bar of length is hanging freely. This is a bar whose length is this and diameter is this. It has cross section area like this. This is its cross section area. Okay, this is its cross section area, and it is elongating. So what is saying? Then the elongation produced in the bar due to its own weight. Like it is again a formula of strain. Okay, it's elongating means it's deforming. So if some deformation is occurring, that means strain formula will work. Okay, strain formula will work. So suppose this is elongated to, suppose this is, okay, the dotted line means the dotted line it denotes that it is elongated due to its own weight or any other kind of force, through any kind of forces. So this is okay. So this is length, okay, and this is a change in length. This is a change in length. So its formula will be, so this is the concept of the question. Okay, this is the concept of the question. So the formula will be this: WL square by 2. Okay, W means specific weight. L means its total length. Total length means total length. Total length means what? Total length means total length means L original, L original, L original, okay, L original plus L, okay, plus changing length, plus changing length, okay. So this is the L, so this is the L, note it down, note it down. Note it down. Okay, and what is this? E. E means Young's modulus. Young's modulus. Okay, this means what? Young's modulus or modulus of elasticity or modulus of elasticity. Modulus of elasticity. Okay, okay. So note it down. Then I will tell you something. I hope you guys noted it. So okay, so the formula of Young's modulus is linear stress to lateral stress. Okay, the formula of okay, one second. I'm removing everything. So formula of Young's modulus. Okay, the correction. Okay, this is correction. One second, I'm doing it. Young's Young's modulus. Young's modulus is linear stress. Hey, one second. I think I've missed something. Linear stress to linear lateral strain. Okay. Linear stress to lateral strain. So this is a correction. I think I have written that linear stress to linear strain in previous. Okay, so the correction will be linear stress to lateral strain. This is the formula of Young's modulus. Okay, remember correction, and you have to remember this correction. Okay, done. So this is for today. I hope you liked it. Okay, if you like my video, then like, share and subscribe my channel, and share these lectures or videos to your friends, to your classmates. Okay, so thank you so much. Thank you for joining in. Bye bye.